There are so many things we don't know about this universe. One of them is space, time, and gravity. We saw about this in the previous video, and as a continuation of that, in this video, we're going to look at the natural marvels that are naturally created in space. First, time travel. Gravity can slow down time, and we would have seen about this in the previous video. Just like how gravity slows down time, when an object moves at high speed, time slows down there. This is what we call velocity-based time dilation. Just like how an object's mass bends space-time and slows down time, when we move through space, space-time contracts in the direction we're traveling, so time slows down. At the same time, the distance we're traveling also reduces. Let's look at this in more detail with an example. Let's take a paper. We can put 2 points on it, one point A, another point B. This paper is space-time, and point A is our location. Point B is the place we need to reach. When we travel from point A to point B at light speed, that paper contracts. That means if you crumple that paper, the distance between point A and point B reduces, and time will be slow for those traveling in that place. When traveling at light speed in a spaceship, time will be fast at the front part of that spaceship, because space-time is contracted in that place. And time will be slow in that spaceship, because space-time is expanded in that place. So if you've watched part 1 of this video, you'll know about space-time in detail. Okay, let's get into the video. You can only see noticeable changes when traveling at the speed of light. But at the same time, no object can travel at the speed of light, unless that object's mass is 0. Because for an object to travel at the speed of light, it shouldn't have any mass. Otherwise, it would require an infinite amount of energy to make that object travel at the speed of light. So practically, traveling at light speed is impossible. But there are a few theoretical ways to travel at light speed. There's a Higgs field everywhere in space. The Higgs field is a type of energy. When an object interacts with this, that object gets mass. So if it doesn't interact with this Higgs field, that object's mass is 0. So that object can easily travel at light speed. But it can't experience time dilation, because any object without mass can't bend spacetime, so it can't experience time. Even light doesn't interact with spacetime, but sometimes light's energy interacts with gravity, so light can bend according to gravity. But it can't experience time dilation, because any object without mass can't bend spacetime, so it can't experience time. Even light doesn't interact with spacetime, but sometimes light's energy interacts with gravity, so light can bend according to gravity. Let's see how they discover this. They take pictures of objects in space using telescopes. In that, small planets behind big galaxies will also be captured. When you hide a needle behind a water bottle and take a photo, there's no chance of seeing the needle in that photo. Similarly, there's no chance of seeing a planet behind a galaxy. But they started researching how it's visible, and that's when they discovered that the gravity of big objects like galaxies bends light. So light coming from a planet very far away gets bent by the gravity of the galaxy in its path and reaches us. And this is what we call gravitational lensing. There are many amazing things like this in this universe, but how would the universe that created all these have formed? The Big Bang is the starting point of this universe. Everything that exists in this universe now started from this point. The Big Bang is a big blast. Everything in this universe was created from this blast. Just like how a balloon gets bigger when you blow it, this universe is also expanding, and everything in this universe travels with that expansion. The universe is expanding much faster than light. They discovered this when observing space through telescopes. All the light coming from galaxies and planets we observe also gets redshifted. That means when light travels a very long distance, it loses energy and changes to red light at the last of the color spectrum. This is what we call redshift. This redshift happens because a galaxy is moving. This can be seen in all galaxies, and with some evidence like this, they confirmed that the Big Bang happened. But at the same time, this expansion has been happening since the Big Bang happened, and the gravity of objects in this universe and some other forces would slow down this expansion. This is what all scientists expected. But what happened was different. The expansion that should have slowed down over time expanded very fast. That means faster than light. A balloon gets bigger only when you blow it. In this place, the air you blow into the balloon is energy. It makes that balloon bigger. Similarly, the universe expanded with the energy created in the Big Bang. But at some point, this expansion should have stopped, or it should have expanded at constant speed, if no external force affected this expansion. But neither of these happened here. Instead, this expansion kept getting faster. So they started researching where the energy to accelerate this universe's expansion comes from. And they found that there are some things in this universe that we can't see with our eyes, and that we can't measure, and that's what creates 95% of the universe. Only the remaining 5% are the galaxies and stars we see. This is called dark energy and dark matter, because we don't have any information about this, because it doesn't interact with any particles. That's why we can't see it and can't measure it. Even the particles in it can't be discovered. That's why we call it dark energy and dark matter. But how did we discover that this dark energy that doesn't interact with anything exists? This dark matter has mass, so it bends space-time and creates gravity, and that's how it bends light coming from far away and sends it to us. When capturing and studying this light, they saw how gravitational lensing happens without any object being there. Then, there's some object in that place. It bends space-time, but they discovered that that object won't interact with any objects. Not only this, stars at the center of galaxies orbit fast, and stars at its edges orbit slowly. But here, stars at the edges also orbited fast, but the external gravitational force needed for this is created by this dark matter. If there's no dark matter, galaxies wouldn't have been created. This dark matter holds galaxies together like glue. With some phenomena like this, they believe in the existence of dark matter, even though it doesn't interact with anything. Now, dark energy. Unlike dark matter, this doesn't have mass, but this energy interacts with space-time, and this is what accelerates the universe's expansion. But they propose a theory that opposes dark energy, which is the Timescape theory. The planets we observe are farther than the distance we expect. This effect happens to all objects in this universe. That's why this universe is expanding and we've accepted dark energy. But what this timescape theory says is that the gravity of the planets and galaxies we observe will be different compared to us. So time will also be different there. Depends on the gravity. And everything we see in space is what already happened. That means we're seeing the past. How? We say the distance between two objects in space is 1 light year. That means it takes 1 year to cover this distance at light speed. That means it takes 1 year for light to come from one point to another point. That means we're seeing now what happened 1 year ago, and we'll see what's happening now only after another 1 year. Based on all of this, in the timescape theory, this universe's expansion is not accelerating. It's a time dilation, they say. So they also say there's no such thing as dark energy. But this is just a theory. A lot of research is happening based on this, and just with this, we can't say the universe's expansion is not accelerating. So many things happen in space that we can't even imagine. Some interesting topics among those are what you would have seen in this video, and I'll see you in the next video with such interesting content. If you like this video, please like and subscribe. Also put your thoughts in the comments. Thank you.